All right, here's our first lesson for 6-1. 6-1, day one. Got some changes coming this semester here. As you would imagine, with the course entitled Functions in Trigonometry. First semester, we've wrapped up our study of functions. Second semester, we move on to trigonometry. Okay, what a classic little place to start by defining the term trigonometry. Okay, seems to kind of smell of triangles a little bit, and you'd be right on the money. Quick thing though, kind of on a random side note, if you think we're all done with functions, you're mostly right. Not totally. The chapter 6 early on kind of makes a mention of it, but there's another family of functions called the periodic functions. They come from like these different trig ratios like sine, cosine, or tangent. Kind of a part of trigonometry is you can look at those trig functions as, those trig ratios as functions. Okay, so that'll come up, and we'll dabble with a little bit of functions at a certain point in time, but not right now. We're just diving into kind of what all this trig stuff is all about. Sure enough, there it is. It is the measurement of triangles, and that would include their sides and angles. Of course, of which they have three. 3 sides, 3 angles. I mean, that takes you back to like your Sesame Street days when you were like 3 or 4. Here's a triangle. 3 sides, 3 angles, okay? But yeah, it's kind of an interesting thing to think that such a simple shape could have an entire high school math course that follows, but triangles are kind of fascinating that way, that the properties and the relationships and the way they kind of relate to geometry in terms of measurement and space, it's kind of amazing as to kind of the crazy amount of possibilities in the world of math that triangles open us up to. All right, a couple vocab things. By the way, today's focus will primarily be angles. Right? If you're kind of getting that vibe that we're really talking a lot about angles, yeah, you're right. Here's your initial side, okay, and your terminal. Okay, your initial side of an angle, right? So kind of getting that mindset that we're talking angles. That initial side never changes. Okay, it always just kind of sits on the x-axis. By the way, this is going to come up too. Just a reminder that we have quadrants, 1, 2, 3, and 4, right? We kind of keep track of, based on what angle measurement we have, what quadrant are we in. One thing, by the way, if you see the term ray, you can think of ray and side for today's lessons kind of as interchangeable, okay? Technically, if you put an arrow on here, a ray is, it's like a line, but it has an ending point on one side and goes infinitely in one direction, but not both. You can think of the sides of an angle as rays. Even if the arrows aren't drawn, you could put them on there because they are, right? You do assume that the sides of these angles, that they theoretically continue forever. If you were to open up counterclockwise, we'd call that a positive angle, right? Let's do a little sketch with each one of those, okay? You'll draw a lot of these today, these little XY axes, okay? And by the way, you'll see this a bunch too. I won't draw it on all of them, but really good to see it now, right? Each of these represents 90 degrees, each quadrant. And I'll label right here that we'd be back at 360, okay? So here's why the quadrants can be really helpful as reference points, because if I were drawing these sketches, what I'm looking for is, all right, 145 degrees. What quadrant am I in? Okay, well, quadrant 2 is for angles that are between 90 and 180. So I'd put it right here. right? There's my terminal side, and then I just mark, right, 145 degrees. So if you were drawing that yourself, I'd expect, you know, I'm not going to be like super picky with the scale because it's just a sketch, but for sure I should see that you're marking your terminal side over in quadrant number 2, okay? Now if we were to go negative 145, right, we could go around the other way, right? It's like this is negative 90, negative 180, negative 270, but it's the same size angle, just going the opposite way. So I'd mark that here. That's negative 145 degrees, okay? I don't know of any like good little trick to remember that. It might just be flat out a memorization piece that positive go counterclockwise, negative go clockwise. You'll draw enough of these sketches that you'll get in the habit that like you start on that initial side and then you just kind of, it's kind of like you feel like you're opening up to the left, which is counterclockwise. You'll get in the habit that that's how we do a positive angle, okay? And then the opposite direction just has to be negative. All right, coterminals. If you have an angle that has the exact same initial and terminal side, you've got coterminals, okay? So here I'm going to draw a bunch of those axes again. If it's okay with you, I'd love, we'll see. I'm only going to put the marks for 0, 90, 180, and 270 if I kind of feel like I need to. I don't want to throw it on all of them. If you're drawing these sketches, I don't necessarily expect that you do. If you need to put those reference points on there, feel free. That's not a bad idea, but you don't have to. It gets kind of tedious. Okay, 58 degrees, by the way. I'll just kind of mark the ones that I think are relevant, right? We're talking quadrant 1, so okay. There's 58 degrees. All right, so a couple different ways to think about coterminal, okay? You could go the negative direction and head that way. Okay, if I wanted to get a negative one, that would work. So now I kind of got to put the pieces together right here. So here'd be negative 90 degrees. Here would be negative 180. Negative 270, right? And so, all right, so I'm expecting an answer even less than negative 270. The question just becomes, what is that little piece right there? Okay, this actually kind of gets ahead of ourselves a little bit with a concept of complements. So really, quadrant 1 forms a 90-degree angle, and I've got 58 right there. So this last little bit right here would be 32, okay? So it's like I go negative 270, and then I got to go another 32. Remember, I'm going in the negative direction. So if I went negative 302, I would end up in the same spot, okay? I'd end up in the same spot. But negative 302 and 58 would be called coterminals, right? Even though I went the positive way for one angle and negative for the other, we got in the same spot, right? And go back to your definition. If angles are coterminals, their initial and terminal side are in the exact same position, all right? Here's another approach we could take to get a positive one, right? Because these questions are asking me 3 parts here. First off, what quadrant are we in? By the way, that was quadrant 1. Give me a negative and a positive coterminal, okay? Here's the other way you can go. Go positive, go all the way around, okay? Go all the way around, so start at 58 degrees, a full trip around the whole coordinate grid is 360 degrees. That would give you 418. There you go. Negative 302 and 418. Okay? So by the way, as far as a little trick I want you to know, to get coterminals, notice I left a little blank, right? Because we're gonna add to that here in a little bit. But you're seeing to get that positive 418 degrees, that's a little trick that you could always use that's just easy without even drawing a diagram. You're given the angle, you can add 360, right? You go another loop around and you end up in the same spot. You could do that over and over again, and all the angles you're gonna get are coterminals. All right, here's my initial side, 500. 90, nope, not there. 180, nope. 270, nope. 360. All right, we add 90 again and get 450. Add 180, we get 540. Whew, here we are. Okay, but here's the thing. I got a mark on here this angle for 500 degrees, which left us in quadrant 2. We did a loop all the way around, and then we kept going, okay, till we got to that spot in quadrant 2, okay? All right, now one approach I could take here, okay, and this is where the other piece is gonna come in here. Let's not do the loop all the way around. That's gonna be the equivalent of subtracting 360 degrees. You could check the math on all these once we have them all done. That's something you can always do. Okay, you can add or subtract 360 degrees as many times as you want, and you'll get other angles that are coterminals to the one that you started with. Okay, so if I did that, I would get 140 degrees. Okay, and if I were to mark that on the diagram, this would be the scenario that if I just went straight there. Okay, if I just went straight there, well, there's a positive angle that's coterminal with 500. I need a negative. Oops. I need a negative. I'll go back and draw my axes. Okay. Initial side, terminal side. Okay, now I'm just gonna kind of break this down here a little bit because I'm already thinking along the lines. I gotta go like that. That's the one I want right there. Okay, let's just go the negative direction. Now, you might be a step ahead of me and look at our definition from up here, right? And you're thinking, hey, 340, can't I just subtract 360, right? I said just a few minutes ago that you had the green light to do that again and again. It'll work, okay? I want to show you on the diagram why this will work, okay? We found that the positive route to that angle was 140, and kind of here's how that's breaking down. 90 and 50, right? 90 gets you to the edge of quadrant 1, then go another 50 degrees, okay? So now if I go negative, I'm going negative 90 this way. I'm going to negative 180, right? That part's easy enough, but then what you've got going on is you have this part right here. This is where going negative can get a little bit tricky, okay? Can get a little bit tricky. How much is left, or how much do we have to go past negative 180, okay? Now, if you think about quadrant 2 forming a 90-degree angle, right, which all 4 quadrants do that, they kind of go in chunks of 90. If 50 has already been taken on the other side, this has got to be 40. Which would put this as negative 220, okay? Now go check your math if you were just doing the algebra approach. should just say the symbolic approach. Doesn't involve a ton of algebra. 140 minus 360, did you get negative 220? I'll bet you did. All right, one more. We'll start here. There's negative 134. Okay. To answer the first question, we're in quadrant 3, right? So now here's the deal, right? You could go a couple different routes with the diagram. You could subtract 360 once and add 360, and you'll get your 2 answers, right? The plus or minus 360, if you're just working with the numbers, is a slick little rule that works pretty quickly. Here's what I'm going to do for my positive one, and understand this is just going to have the effect of adding 360. I'm just going to go that way. Right? So that gets me to 90. That gets me to 180. Oh, and it kind of leaves this question right in here. How much past 180 do I have to go? That's my question. Well, if I go the negative way, I went... And now I know it's a little bit different, that I went backwards, so I have to think about it as negative, right? I'm going to write these in as positive, but know that they really should be negative. I went 90 degrees here, okay? But then in terms of going past 90 degrees, I had to go another 44. Another 44. Which means right here, I've got another 46, right? Because those 2 parts of quadrant 3 have to add up to 90. Okay, so 180 plus 46, there's your positive, right? Now that can get a little bit tricky on the diagram, and you might be thinking, you're telling me I could have gotten from negative 134 to 226 just by adding 360? Yep, sure could. All right, last one, we need a negative. Okay, and here's the way we're gonna have to do it. We gotta go here and then go all the way around, okay? There and go all the way around, and here I think the rule is really handy, right? You're at negative 134, okay? All you're really doing by doing an extra revolution, an extra trip around the whole coordinate grid, is taking away 360. Negative 494 degrees. Okay. There's a bunch of stuff on coterminals. Okay. The concept will come up later on as to like why in trig they're kind of a significant thing, but that's not really for today. Here you kind of know what they are and how you find them. All right, degrees, minutes, and seconds. This is just kind of a quick hitter because we don't spend a ton of time on it. So there's this old school way that you don't see a ton anymore, but I think it's just kind of fun to bring it up, where you still see it in kind of a different measurement system that you'll see it with, like latitude and longitude of like degrees, minutes, seconds. Okay, 1 degree, once upon a time, was defined to be 60 minutes, and 1 minute was defined to be 60 seconds, which that math would lead us to say 1 degree is like 3,600 seconds. Okay, so it was kind of used for a long time, and still is today, as a different way of defining like decimals of an angle. Okay? I want to show you how to just convert back and forth. Okay? That's all I really want to do with, minutes and seconds. All right? So just to recap here, so you know the symbols. 1 degree equals 60 minutes. So that's like kind of sub portions of 1 degree. 1 minute equals 60 seconds. So then 1 degree equals 3,600 seconds. Okay. All right, so convert 37 degrees, 21 minutes, 33 seconds, right? That's degrees. That's minutes. That's seconds, okay? Okay, here's how it works. Once you find your minutes, right? Remember, there are 60 minutes in 1 degree, so we do 21 over 60 plus 33 over 3600. And there's your seconds, right? Those numbers on the bottom would never change, right? It's always over 60 and always over 3600 for minutes and seconds. From here, this whole thing, you would just type into your calculator. And you would get 37.359 degrees, okay? You'll see, we'll use the decimal more. I just think it's kind of cool to know the conversion as to how to go back and forth. So let's do the opposite, okay? Let's do the opposite. 83.41356, okay? Now, first of all, for the degrees, I've already got it, right? It tells me 83, okay? I need to fill in how many minutes, how many seconds, okay? So again, when we're saying minutes and seconds here, we're not talking about a measurement of time. It's like a much smaller measurement of an angle, right? Which you have the conversions up top. 1 degree is the same as 60 minutes, okay? So when you're thinking about like in terms of an angle measurement, a second is quite small, right? 1 degree would get split up into 3,600 seconds. But here's how it works. When you take away 83, all you have left of the angle is 0.41356. Okay, go ahead, multiply that by 60. You will get 24.8136. Okay, the number we really need is right there. That means we have 24 minutes. The decimal that's left over needs to come down here, 0.8136. We have to multiply that by 60 again. And we get 48.816, 48 seconds. 83 degrees, 24 minutes, 48 seconds, okay? The degrees, minutes, seconds thing can get a little confusing. Just know that all you ever really need to know about the minutes and seconds is on this slide. I expect that if you were given, like a problem just gets kind of tricky and gives you the angle in minutes and seconds, that you could convert it to degrees, okay? In terms of like doing any math with the angle, there's probably not a scenario where we'd say, oh, I have it as a decimal, I want to convert it to minutes and seconds, which is the example on the right side. I would just expect that you could do that. But in terms of like a bigger problem, unlikely that you'd be asked to. Okay, but you should know how to convert either way. All righty. Last topic. Complementary and supplementary. We already talked about complementary a little bit. If you got two angles and their sum is 90 degrees, we call that complementary. If you've got two angles and their sum is 180 degrees. Okay, it basically looks like this, that here's complementary. If you have these two angles, right, we'll call it angle number 1 and 2, and together, you stick them together and they form a right angle. We call that angles that are complements. When we were doing coterminal angles, we saw that come up, right? We worked with that a little bit on those angles as we drew them on the quadrants. We used the idea of a complement. So that one does come up a lot. If you've got angles that are supplementary on a diagram, what you're going to see, here's 1, here's 2, is you'd stick them together and they would form a straight line. okay? You'd stick them together and they'd form a straight line. They're pretty easy to work with, right? All right, find the complement of 35 degrees. Good enough, right? 90 minus 35. Nothing to it. Supplement, 180 minus 35, 145, right? You could be wondering, like, okay, if you give me an angle and you want me to find the complement and supplement, is it that simple? It is that simple. Okay, it's an important topic because it's one of those where it's like it's usually a part of a bigger problem as we go through the semester, right? And it's a concept that doesn't really go away. We find ourselves using it again and again. Okay, right here, complement, none, right? Why? 127 is bigger than 90, right? I need to take 90 minus the angle. That would give us a negative. It doesn't work that way. If you've got an angle that's over 90, we just say it doesn't have a complement. Supplement, 180 minus 127, 53 degrees. Right, now if you want to put, just to kind of illustrate on the diagram, it's not really drawn to scale that well, but it's not terrible. You know, if you were to say over here that angle 1 is 127 degrees, that would mean if there's supplementary, angle 2 over here would have to be 53. And if you slid those angles together, you get 180 degrees or a straight line. All right, that'll do. That's all for 6-1 day 1. More to come in day 2.